Hello students, in our last class we have discussed IUPAC nomenclature of aldehydes and ketones. So today we will discuss chemical methods of preparation for aldehydes and ketones. So there are several methods of preparation for aldehydes and ketones, and among them some methods are you have already studied in chapter 11, that is alcohols, phenols and ethers, and some methods are you have studied in class 11. Okay, so in this class we will discuss the new chemical methods which are used to prepare aldehydes and ketones. So at first our heading is methods of preparation for aldehydes. So let us take the heading as preparation of aldehyde, and the first method is from acyl chloride. Okay, and this reaction has a special name, and the name is Rosenman reduction. So during this method acyl chloride is used. This one is acyl chloride, this one is carboxylic acid. When the OH group of carboxylic acid is removed or replaced with chlorine, then the compound formed is known as acyl chloride. Okay, and when acyl chloride is reduced, that means reduction means addition of hydrogen. When acyl chloride is reduced in presence of palladium and barium sulfate, then the chlorine is replaced by one hydrogen and the resultant product is aldehyde, and the side product is HCl. One hydrogen will combine with chlorine to give HCl. Okay, so for example, we have suppose CH3 C double bond O Cl, and we are reducing this compound using hydrogen in presence of palladium and barium sulfate. Okay, and then the final product is CH3 C double bond OH, and then the side product is HCl. Okay, again another example is suppose we have this compound, the reagent is same, hydrogen in presence of palladium and barium sulfate, and the product is this one, only the chlorine is replaced by hydrogen. So this one is ethanol. We have already studied about the IUPAC nomenclature of aldehydes and ketones. Okay, this one is ethanol and this one is benzaldehyde. Okay, so this reaction is known as Rosenman reduction, and the reaction is very important. In exams, generally questions are asked from Rosenman reduction. And after that, the next method is, that is number B, from nitriles. From nitriles. Okay, and this reaction has also a special name, and the name is Stephen reaction. The reaction is known as Stephen reaction. The reaction is known as Stephen reaction. So nitrile means, suppose we have RCN, okay, or RC triple bond N. So this organic compound is known as nitrile. Okay, and during Stephen reaction, the nitrile is reduced with SN Cl2 in presence of HCl, and during reduction one hydrogen will added to this carbon and another hydrogen will added to the nitrogen, forming CH double bond NH. So after hydrolysis, the final product is RCHO, that means one aldehyde. Okay, so this compound is known as nitrile, this one is known as imide, okay, and then the final product is aldehyde. So when nitrile is reduced with SnCl2 in presence of HCl, then imide will form, and after hydrolysis the imide is converted into aldehyde. So let us take one example. Suppose we have CH3CN. So when we will add SnCl2 in presence of HCl to this nitrile, okay, and then the product is CH3CH double bond NH, okay, and then after hydrolysis the final product is CH3CHO. That means we are converting a nitrile into aldehyde with the help of Stephen reaction. Okay, so in place of this SnCl2 and HCl, we can again use diisobutyl aluminum hydride, diisobutyl aluminum hydride, and in that case the product is same. That means the nitrile will convert it into aldehyde. Suppose we have one nitrile, and at first we are using diisobutyl. This represents isobutyl. There are two diisobutyls, therefore diisobutyl aluminum hydride. Then the product will convert it, the nitrile will convert it into imide, and after that in second step when we will learn acid hydrolysis, then the nitrile will convert it into aldehyde. Okay, this one is nitrile and this one is aldehyde. Okay, for example, suppose we have CH3 CH2 CN. Okay, at first we are using diisobutyl aluminum hydride. Okay, in second step the intermediate product is hydrolyzed, and then the result is CH3 CH2. Okay, this part will convert it into CHO. Okay, then another example, suppose we have CH3 CH double bond CH and CN. Similarly, we are using diisobutyl aluminum hydride, after that acid hydrolysis. Okay, and always remember that diisobutyl aluminum hydride will not reduce carbon-carbon double bond. That means this compound will not add hydrogen to the carbon-carbon double bond. It will only add hydrogen to the carbon-nitrogen triple bond. In this case, one triple bond is there. We have already seen in previous example. Okay, so this compound will convert it into CH3 and then CH, then carbon-carbon double bond, CH and then CHO. Only this part, that means the CN part, will convert it into CHO. So this is another method by which we can prepare aldehyde from nitrile. Earlier we have prepared aldehyde from acid chloride or acyl chloride. That reaction is known as Rosenman reduction, and then in this reaction we have prepared aldehyde from nitriles. Then let us discuss another method by which we can prepare aromatic aldehydes, that means the benzaldehyde. And generally benzaldehyde is prepared from hydrocarbons. So number C, from hydrocarbons. Okay, so number 1, we can prepare benzaldehyde using chromyl chloride, by using chromyl chloride, and the formula of chromyl chloride is CrO2 Cl2. So suppose we have this compound toluene. This compound is known as toluene. So when at first we will use chromyl chloride in presence of carbon disulfide as solvent, this one is carbon disulfide, okay, and after that in second step, if we will do acid hydrolysis, then the CH3 group will convert it into CHO. That means toluene will convert it into benzaldehyde, and benzaldehyde is an aromatic aldehyde. Okay, so in next step or in next reaction, we will prepare benzaldehyde by using side chain chlorination. Side chain chlorination. Suppose we have again toluene. So when we will add chlorine in presence of UV light, then one hydrogen will be replaced by chlorine. Okay, the CH3 will convert it into CH2 and then Cl. Okay, and then again when we will use chlorine in presence of UV light or sunlight, then another hydrogen will be replaced by chlorine and the product is CHCl2. Okay, and then when we will do acid hydrolysis, to the disubstitute or dichlorinated aromatic compound, then the final product is benzaldehyde, CHO. So again we can convert toluene into benzaldehyde by using this chemical reaction. Okay, so another method of preparation of benzaldehyde is by Gattermann-Koch reaction. So number 3, by Gattermann-Koch reaction. So in this particular reaction, benzene is used. Earlier we used toluene, but in this particular reaction, benzene is used, and to the benzene, carbon monoxide is added in presence of HCl, and anhydride AlCl3. Okay, and then CuCl, then one CHO group will attach to the benzene ring, resulting benzaldehyde, and this particular reaction is known as Gattermann-Koch reaction. So we have learned how to prepare aldehyde. At first, we have prepared aldehyde from acid chloride or acyl chloride. That reaction is known as Rosenman reduction. Then we have prepared aldehyde from nitrile. That reaction is known as Stephan reaction. And then we have prepared aromatic aldehyde, that means benzaldehyde, from hydrocarbon. At first we have prepared from toluene by using chromyl chloride and then acid hydrolysis, and again by side chain chlorination and then acid hydrolysis. And in this particular reaction, which is known as Gattermann-Koch reaction, we prepared benzaldehyde from benzene using carbon monoxide in presence of HCl and anhydrous AlCl3 and CuCl. Okay, then very simple reaction, one CHO group will attach to the benzene ring. Okay, now let us discuss the methods of preparation for ketones. So now our heading is preparation of ketones. So the first method is from acyl chloride. Earlier we have done Rosenman reduction to prepare aldehyde, but in this case the Rosenman reduction cannot prepare ketones. In this method, one Grignard reagent is used, and that Grignard reagent react with cadmium chloride to give dialkyl cadmium and then magnesium chloride. Okay, dialkyl cadmium and magnesium chloride. And now the dialkyl cadmium react with acyl chloride. Okay, suppose we are using different alkyl groups, acyl chloride, to give the ketone. Okay, again the side product is cadmium chloride. Okay, for example, suppose we have CH3MgCl. So when CH3MgCl will react with cadmium chloride, then we will get CH3-2CD, that means dialkyl cadmium or dimethyl cadmium, and then magnesium chloride. Now in next step, suppose we have CH3C double bond OCl, and with this acyl chloride, when dialkyl cadmium will react or dimethyl cadmium will react, then the product is CH3C double bond O CH3, and the side product is cadmium chloride. So by using dialkyl cadmium or a particular alkyl cadmium, okay, in this case we are using dimethyl cadmium, we can convert acyl chloride into ketone. So this one is a very simple and easy method for preparation of ketones. In next reaction, we can convert one nitrile into ketone, again using Grignard reagent. So number B, from nitriles. Suppose we have one nitrile RC triple bond N. Okay, when this nitrile will react with Grignard reagent, suppose R dash MgX. Okay, then the R dash group will attach to the carbon. Then one pair of electron from this triple bond will move to the nitrogen atom. Okay, and then the product is RC, and the R dash will attach with this carbon. Okay, and then we will have one carbon nitrogen double bond. Earlier it was triple bond, but one electron pair is moved to the nitrogen atom. Okay, so the nitrogen will get negative charge, and then when this compound will break, this Grignard reagent will break, we will get R negative, and then MgX positive. This MgX positive will attach to the negatively charged nitrogen atom. So finally, when we will do acid hydrolysis, then the product is RC R dash double bond O. That means we will get one ketone. Okay. For example, suppose we have this compound CH3, CH2, C triple bond N. Okay, propane nitrile. There are 3 carbons in this compound, therefore the name of this compound is propane nitrile. Okay, so when propane nitrile will react with this Grignard reagent, suppose C6H5 MgBr. Okay, and then this group C6H5 group will attach with the carbon atom, and one electron pair will move to the nitrogen atom, resulting CH3, CH2, okay, and then C6H5, okay, one carbon nitrogen double bond, and then MgBr. So after acid hydrolysis, we will get CH3, CH2, C6H5 double bond O. So this one is one aromatic ketone. Okay, so we have learned how to prepare ketone from nitrile. Okay, so the last method is from benzene or substituted benzene. So number C from benzene. So this is a common reaction you have already studied, and the name of the reaction is Friedel-Kauf acylation. So when benzene will react with acyl chloride CH3, C double bond O, Cl, okay, in presence of anhydrous AlCl3. In Friedel-Kauf reactions, the reagent which is used is anhydrous AlCl3. Then the bond will break here, resulting C double bond O CH3 positive, okay, and then Cl negative. Okay, and this portion, that means this part of this acyl chloride will attach with the benzene ring, replacing one hydrogen atom, and that H positive ion will combine with chlorine to give HCl, okay, as side product. So when hydrogen will be replaced by this group, then the product is C double bond O CH3. So this one is known as benzophenone, an aromatic ketone. So these are some common methods by which we can prepare ketones in laboratory. So in today's class, we have learned how to prepare aldehydes and ketones by using some chemical methods. So in our next class, we will discuss chemical reactions of aldehydes and ketones. So that's all for today's class. Thank you.